Welcome back guys, Jimmy Jules 153 here with another Dreams Logic tutorial. Today we'll be going over the node gadget and how we can use it in our logic. Nodes are a very simple gadget and they don't process any information, but rather pass the info along to other gadgets. They can be used for many things, from making custom microchips to holding a color so that we don't have to have a sculpt. But we'll go through these examples soon. In nearly every logic setup I do, whether it be simple or complex, I use a node somewhere along the way. We'll go through the uses I found for them so far. First of all, this is a node. It comes with just an input and an output, and it'll pass any signal it receives from the input port to the output port unmodified. For our first example, on the tweak menu for our nodes, down the bottom, we have a few options under Create Port. The first option is No Port. The second option is Input Port, and the next is Output. We have our node on the left over here set to create an input port, and the one on the right creates an output. You can see that the node that creates an input has a line coming from the left side of the microchip, and it's the opposite for the node creating the output. Our two nodes up the top are set to the No Port option. If we close our microchip here, you can see that we have two input ports and an output port now on it. These ports are created by the nodes so that we can wire things directly into the microchip without having to open it every time. You can see that the ports also have the icon of the node that we set, so it's easily definable when we go to plug something in. If we plug this node here into the controller port and open the chip back up again, you can see that it's now wired into the node as though we plugged it directly in. You can have a maximum of about 660 custom input and output tags in the one scene before you hit a limit, but I don't think you'd hit that limit very quickly as it's a huge amount of custom ports. You've got a selection of 23 different custom icons, and you can also change the color of the node too. When you change the color, it also changes the wire color coming from the node. You can see that at the moment the wire is red, but if we change the node to blue, the wire will change to blue as well. This is just another way that nodes make things easily readable. For this next example, we'll go through how nodes can make our lives easier when it comes to wiring things up. We've got a simple setup here, just randomly picking a percentage that it's sending to the color wheel of the sculpts. Both of these things here are wired up differently, and they're doing the same thing, but one is a much easier way if we want to change things down the track or add additional pieces. With the sculpt down the bottom, each of the individual value sliders is plugged into the color wheel of the sculpt. This is a fine way to wire this, it does work. For the top sculpt, we've got all of the value sliders plugged into one node. Then the node is plugged into the sculpt's color. This way we only have one wire going into the port, so it makes things easier to read for a start. But if we also wanted to have the cube above added to this setup, if we were to wire it the same way as the bottom sculpt, we'd have to wire each of these value sliders back into the color wheel of the new object, in this case the cube, and that is a bit tedious. However, if we wire it up with a node like we have with the top sphere, because we've only got one wire to deal with, we can just plug the output from the node directly into the color and it's away. This can actually also help save on gameplay thermo if you have a large setup with a lot of wires. If you wanted to wire 50 sculpts up like this, with the bottom wiring setup, you'd need about 200 wires, which is a lot when you take into account there's a maximum of about 7,500 wires before they stop rendering. If we wired 50 sculpts with the node, however, we just need the 4 wires going from the value sliders to the node, plus 1 for each of the 50 sculpts, so that'd be 54 wires compared to 200. As each wire does take up a tiny amount of gameplay thermo, a saving of 146 wires will make a difference. Nodes can also be used to store colors. We've got 4 nodes here, all with different colors set in their tweak menus. And we've got all of these colors going into the top node that's called color. We've got the default outputs from the nodes going into the node output node down the bottom here. You can see that as each of the nodes powers on, it transmits the color to the top node but not the bottom. If you're using nodes to store a color, just make sure you wire directly from the color wheel on the tweak menu and not from the default output port. You can also see that the nodes change colors if they're receiving a fat wire with an RGB signal. Nodes can also be powered off, and when they are, they'll block any signal from leaving the output port. You can see that even though the switch going into the node input is turned on, the signal to the sculpt isn't getting through because the node's power is turned off. To wire something to the node's power port, you have to open the tweak menu because they don't show on the face of the gadget. You then just plug the wire directly into the power button at the bottom. For our second to last example, we'll be going through a potential use for the isInput wired output on the node. This output will be turned on when there's something plugged into the input, and off if there's not. You can see that when we plug something in, the signal manipulator turns on, and when we unplug the wire, it turns off. Now you might be thinking, how would something get unplugged during the game, and how would I use that? Well, there's a few things this could be used for, but for this example, we'll use a destroyer. The last update for Dreams fixed a bug with the destroyer, so you can use the affected object output properly now. Thank you very much, OM, for that. And with this fix, we can now plug the affected object output directly into a microchip that we want to destroy. Let's say you've finished with your microchip, and you don't need that logic for the rest of the game. You can grab the affected object output and select the microchip. This will plug it into the side of the chip, so that's how you know you've done it right. When our time is finished, it's going to pulse our destroyer to destroy the microchip, and the isInput wired output from the node will turn off because there's no longer a wire going into it. We've got our isInput wired signal going into a NOT gate, so when the chip gets destroyed, it's going to freeze the signal manipulator. For the final example, we'll just quickly go through how you can make custom microchips. You can have complex logic setups, and only have a few inputs and outputs required for it to work. So you can expose these inputs and outputs to the face of the microchip to make things easier for yourself and the other creators using it. You can make it easy enough that they don't need to open up the chip at all for it to work, which really helps people who didn't design the chip make the most out of it. You can see that we can have custom names for our ports just by naming the nodes, so you can give hints to yourself or others as to what should be plugged into that port. I think that's just about all. I hope you enjoyed the video, and I'll see you in the next one.